All right. This is problem number 6 on our first quiz, second quiz, something like that. This is a thief is running at a constant speed of 6.0 meters per second. His car is 25 meters away from him when a policewoman, change that to purple, starts chasing him and she is 5 meters behind him. Policewoman was walking at a rate of 1.0 meters per second when she began to give chase and accelerating constantly at a rate of 3.0 meters per second. Does she catch the thief before he gets to the car? Fully support your answer. Well, first things first, right? What is the what are we trying to find, right? Does she catch him, right? I guess I don't know. We could change this to blue. Does she catch him before he gets to the car? So we're looking for a yes or no, right? Um, so there's that weird box he wants you to fill out with like, what you're looking for, and the sign of it is going to be positive or negative. That's not really applicable. And the units, obviously, yes and no don't have a unit, so yes or no should suffice. Anyway, first thing we want to do is draw a little picture. I'm realize I'm really bad with pictures, so we're just gonna use colors. We got a red dot here. This is gonna be our um, robber, right? We can name him Rob. It's horrible. You tell this is my first one of the day. Then we have an endpoint here. This is his car, right? And then we have a policewoman behind him. So I'm gonna name her Policewoman. We gotta draw an XY, not an XY, just an X coordinate. So we're gonna say this is the positive direction, that's the negative. This is the final. So like final position here is gonna be 0. That's the goal here. Robber, he's 25 meters away from that, right? 25 meters. So we could do like a starting position of, well, I mean, see, this is the thing. You could you could do 30, I guess, would be easier. Like, right? So this guy could be negative 25, she could be negative 30, car could be 0, right? Just based how we did it. Or to make it easier, we can have the final position be 30 and have him start 5 meters in and have her start what would be x0 initial starting point. Then we'd have his x0, his initial starting point, to be equal to 5. Both of their finals are going to be the same. Oh, come on. I don't know if it's making it more complicated or not. Anyway, we know if we can start filling in our other stuff, it looks like the thief is just running at a constant 6.0 meters per second. So his velocity is going his final velocity is going to be 6.0 meters per second. I'm pretty sure it would also mean his initial velocity is also, trying to make this neat, getting good habits here, would also be 6.0 meters per second. Whereas Miss Lady her initial velocity, well, let me do her final velocity. Well, we don't know her final velocity, right? We just know that she started off with an initial velocity of 1.0 meters per second, and she was accelerating at 3.0 getting sloppy meters per second squared, right? So we know both of their initial positions. We know the final position we're trying to find out. Well, we know, but that's what we're measuring. We know robber or thief, he's got the constant velocity of 6.0 meters per second. I don't know if that's Vx or Vox or if it's both of them, so that's a big fucking question mark. Uh, we know the policewoman. We don't know her final velocity, right? We do know that her initial velocity is 1.0 meters per second, and she's accelerating at 3.0 meters per second squared. I'm pretty sure that's all the things that we have. Another thing that we don't have is the time. How long does it take her to get there? How long does it take him to get there? And is she faster? Or get there sooner? Da, 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 da. Try to make this not take up the whole screen. Alright, so we have all kinds of things we can do here. We should probably do the robber first. We want to find time. We don't know his acceleration. Or do we just put his acceleration to be 0? See, that's like the super trippy part for me. Like this is messing me up. He's got a constant speed of 6.0 meters per second. If he's got a constant speed, I'm going to assume that his acceleration is a big fat 0 meters per second squared. Right? Because if he's not changing, easy. So, this is like super small. I'm kind of eyeballing this bottom left one. If we have 0 meters, or if his acceleration is 0, that means his final velocity equals his initial velocity. I mean, I guess both of those are true. But then if we divide it by 0, we get undefined, so that wouldn't help us find time. I think we're going to use this one. Because we know his final position, we know his initial position, we know his initial velocity. We're trying to find time, so that's a big fat unknown. And then 1/2 0 acceleration times time squared just wouldn't be a thing, right? So let's use that one. This, I think. be Rob. So final position we know is going to be equal to 30. That's meters. Forgot to put that here. His initial starting position is going to be 5 meters. His initial velocity of x, right, is going to be 6.0. Another 0, 6.00 meters per second. And that's going to be times time. Then it would technically also be plus 1.5, and that would be 0, right? Times time squared. Obviously, all of this just cancels out, so we're not worried about it. We're just left with this part right here. So if we solve for t, what we do is we subtract 5 meters from both sides. We get 25 meters on the left is equal to 6.00 meters per second times time. Really bad with these sixes. Perfect. It's horrible. We're going to divide both sides by 6.00 meters per second. So this is going to cancel out. We're left with basically our time is going to equal 25 meters over 6.00 meters per second. Now, since we're dividing 25 meters by 6.0 meters, our meters cancel out. The only unit we have left with is time. So if we bring out a handy dandy calculator, we have 25 divided by 6 is going to give us 4.66666666 meters, seconds. 4.1, and we'll round that, right? Because it's 3 significant figures because of 6.00. That rounds to 6.17 seconds. We can just put an S, it's fine. So that's when our robber gets there. The question is, does Mrs. Police Lady get there before him? So let's bring up our equation sheet. Which one are we going to use? Can we use the same one? I mean, we can use the same one, right? We can use that same equation. The only difference is instead of our AX being 0, we're actually going to have to plug in those values. So that's kind of neat. Change to purple. We got police woman. All right, what's her starting position? Or sorry, what's her final position or ending position? We got 30 meters. And that is going to equal x0. That's her initial position. We know she's 5 meters behind him because of our coordinate system and how we labeled this. She's basically starting out at that 0. And that would be negative if we went that way. But she's 0. Easy peasy. 30 meters equals 0 meters. We're looking for our initial velocity for her, which we know to be 1.0 meters per second. She's walking pretty quick. before she started chasing him. So it's 1.0 meters per second. That'll be times the time, which we're trying to figure out. That's plus 1/2 ax is our acceleration, constant of course, 3.0, and that is meters per second squared. And that is going to be multiplied by time again, squared. Perfect. Now, I'm not sure you could solve this without using the quadratic equation. Maybe you could. But the quadratic equation is a lot easier to do that. If you remember the quadratic equation, I don't think he's got it on his equation sheet. It's a shame. Nope. Oh, yes. Right here. Boom. I know, crazy big. Basically, for the quadratic equation to be usable, we need it to first be set to 0. So we got to get everything on the same side. That means we need to get, we're going to minus 30 meters from both sides. Basically, you have all of this, instead of 0 meters, you have negative 30 meters. Now, ooh, he even has it here. Look at that. Dude, this is perfect. AT, right? Acceleration time squared. That'll be your A value. BT, that's your initial velocity times time, so it's that value. I guess I should write this in. AT is going to be 1/2 times 3.0 meters per second times time squared. Now, you want to be careful here because you might just want to put in 3.0, but that's not right. We need to actually factor in our 1/2 into our 3.0. So that'll end up giving us 1.5 t squared. Maybe this will make more sense now, because we have AT squared. This is our A, and obviously that's our t squared. So our value for A here is going to be 1.5. Don't worry about units. We're over it. The value for B, BT, right? We have 1.0 meters per second over T, or times T. That's it. Easy. 1, right? You could put 1.00 if you want. Our value for C is that constant, which would be our negative 30. So basically, the biggest thing with the quadratic formula is making sure your A, your B, and your C are the correct numbers, or else it's not going to work out. If we actually plug these numbers in, it's fairly straightforward. We have negative B, so it'll be negative, and our B was 1, is plus or minus the square root of B squared. Remember, B is 1, so we'll do 1 squared, minus 4AC. So minus 4 times A. We said A was 1.5. and that's times c, which is negative 30. All of that is going to be over 2a. So 2 times a, which is 1.5. Holy cow. I did way too much physics the other day. I'm so burnt. Hopefully I don't make a mistake. If we simplify this, um, we get negative 1 plus or minus the square root of 1, because 1 squared is 1, minus, what is, 4 times 1.5 times 30. It'd actually be negative 30. Well, that didn't work. 4 times 1.5 times... Well, it's negative 180. That's what you should have had. And all of that is going to be over 2 times 1.5 gives you 3. You can further simplify this to be negative 1 plus or minus 1 minus 100, negative 180 is going to be 181. So we're going to take the square root of 181. That'll give us 13.45. 453. All over 3. So, I mean, if you're not familiar, there's two possible solutions that this equation is giving us. One of them is not going to work, and we'll see why very shortly. So, if we have negative 1 plus 13.453, it's going to give us 12.453, and that's all over a third, which is equal to 12.453 divided by 3, 4.151. And that'll be in seconds. So that's our first zero, or our first answer, right, to the question. Just for simplicity, we're going to try putting in the negative. So the other solution this gives us is negative 1 minus 13.453 all over 3. Technically, that's all over 3 as well. So if we have... This calculator is negative 1 minus 13.453 gives us negative 14. Negative 14.453. Oh my goodness. Control Z, undo. And that'll be over 3. I mean, you can see here it's a negative number, so it's not going to work, but just to finish it off, negative 4.818. That is our other solution, and that's seconds as well. Obviously, you can't go negative with seconds, at least with one-dimensional kinematics, so we can just get rid of this solution. Our other solution, 4.151, excellent. 4.151 is our, in seconds, that's our police lady time. We can see that 4.15 is less than 4.17. So, does she catch the thief before he gets there? Yes. Right? Um, this, looking at it like this, now that it's finished, looks like a crazy big nightmare of a mess, but I hope this made sense. Maybe some of the little steps that might have usually gotten lost got fixed. If you have any questions, just let me know. As always,